Time for more factoring. Today we're going to be factoring quadratic trinomials with a leading coefficient that is composite. Remember that quadratic means the highest term is squared. Trinomial means that there are going to be three terms. The leading coefficient is the number in front of the variable with the highest exponent. And this time that coefficient is going to be composite. Composite means that that number is going to be divisible by numbers other than 1 and itself. The main thing that you're going to notice is that we're going to follow the same steps as before, but now when we fill in that f times f spot, since that number is going to be composite, there's going to be more possibilities. So let's go ahead and put same steps as before. But now the f times f spots have more than just one possibility. Let's look at an example. 6x squared plus 19x plus 15. We want to start out the same way. So our very first step is always to check if there's a greatest common factor. Is there a number that can go into 6, 19, and 15 all at the same time? And the answer to that is no. So we're moving on. The next thing that I always check is the signs. Remember, when you've got three terms with a plus at the end, the signs are going to double up. And since the middle term has a plus, my parentheses are going to have plus, plus. Okay, that makes it a little bit easier. The next thing I'm going to work on is those f spots. This time, f times f is 6x squared. So I have a couple of different possibilities. I could have x and 6x, or I could have 2x and 3x. So what I will usually do is I will start with one of them, and then I will try every possibility and then switch to the other. You'll notice that I'm now going to be working with a pencil because there's going to be a lot of guessing and checking and erasing. So I'm going to start with trying x and 6x. What I'm checking that with is the L spaces. And in this case, the L times L term has to equal 15. So the possibilities are 1 times 15 and 3 times 5. What I'm checking with those is to see that the O term plus the I term needs to equal that middle term from the problem, 19x. So I'll just start with 1 and 15. So I'll put 1 and 15 here. X times 15 is 15x, and 1 times 6x is 6x. When I add those together, I get 21x, which is not the 19 I was after. So we've got to erase and start again. I'm going to leave the first two terms and just change the second ones. When you have coefficients on your first and first, you have to check 1 times 15 and 15 times 1. So we'll switch that and make it 15 and 1. I can already tell that's too big because 6 times the 15 is going to be way bigger than 19. So that's not going to work. I'll just erase those. And the 1 times 15 doesn't work in this with the 6 and x. 6x and x. So I'll try 3 and 5. 3 and 5. X times 5, 5x. 3 times 6x, 18x. That makes 23, which is bigger than 19. So I'll try 5 and 3, just switching those around. X times 3, 3x. 6 times 5 is 30x. That's already too big. Okay. So I've tried every possibility with x and 6x, which means that x times 6x is not going to work. So I've got to try 2x times 3x. So let's try 2x and 3x. And then I start back with 1 and 15. So 1 and 15. 2x times 15 is 30x. That's already bigger than 19x. So that's not going to work. How about 15 and 1? That's already 45x, so that's not going to work either. So on to 3 and 5. 3x, excuse me, just 3, not an x, and a 5. That's 2x times 5 is 10x. 3x times 3 is 9x. Oh, and that adds up to be 19x. So that's the combination that's going to work. So we're going to have 2x plus 3 times 3x plus 5. And to check our work, we could FOIL that. So 2x times 3x is 6x squared. And then outsides are 10x, insides are 9x. Those add to 19x. Last times last is 15. Just stick with these. You will either eventually find one that works, or if you go through all the possibilities and all the different orders and nothing works, then it's possible that you have a trinomial that's not factorable, which we call prime. Let's try a couple more examples. Let's go negative 32x squared minus 24x plus 20. When I'm looking for a greatest common factor, I will tell you, I don't like to factor a trinomial or any kind of polynomial that starts with a negative number. So I'm at least going to factor out a -1. If I have a larger number besides one that will come out, I'll take that out as well. So I'm at least going to go negative something. And all of these numbers are divisible by 4, so I'll be taking out a -4. So I'll put my -4 out in front and divide each term by -4. So that's going to leave me with 8x squared and then plus 6x and minus 5. You want to be really careful with the signs, because if you get your signs wrong, then your factoring is not going to be right either. Let's check the signs, by the way, since we're still talking about it. When you've got 3 terms with a minus at the end, the signs are going to be opposites. So this tells me it's either going to be plus minus or minus plus. That makes it a little bit more challenging. And then my first times first has to be 8x squared, so that's either going to be x and 8x or 2x and 4x. And then my last times last, it's nice when that's a prime number because the only possibility is 1 and 5. Of course, we could switch that and make it 5 and 1. You want to remember to always check both orders when your leading coefficient is not a 1. So let's go ahead and start checking some stuff. I got -4, parenthesis, 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 parenthesis. Okay. Switch to pencil again. Let's try with x and 8x. Again, I'm checking to see that my O term and the I term need to have a difference this time because the signs are going to be different. Have a difference of 6x. So I'll try 1 and 5. So I've got x times 5 is 5x, 1 times 8x is 8x. That is a difference of 3x. So let's try a 5 here and a 1 here. 5 here, 1 here. X times 1 is x. 5 times 8x is 40x. That's a difference of 39x, so that's also not going to work. I've tried all the possibilities for x times 8x. So now I'm going to go on to 2x times 4x. So 2x and 4x. And I start back over 1 and 5. So 1 and 5. 2x times 5 is 10x. 4x times 1 is 4x. The difference between 10x and 4x is 6x. So this is the combination that's going to work. We just need to figure out the signs. Since I'm looking for a middle term of positive 6x, that tells me that I need positive 10x and negative 4x to get that positive 6x. So the 10x needs to have the positive. So the 10x came from the outside terms, so the plus is going to go right here, which gives me positive 5 times 2x. And the minus needs to go on the 4x, so the minus sign goes in here for 2x minus 1. So I end up with 2x minus 1 times 4x plus 5. I know this seems like it takes a really long time to factor one problem, but I promise you, the more problems that you factor, the better you're going to get at guessing what's going to work the first time off, so it takes less and less time with more practice. Or some people are just lucky and they're just really good at guessing the first time. This problem here, we're going to start out again the same way. Is there a greatest common factor that can divide out of 10, 37, and 12? Well, 37 is a prime number, and so nothing's going to come out besides 1 and 37. So the answer to that is no, although I see that we start with a negative number. So I'm going to factor out a negative 1. That's just going to change the signs of all the terms. So I'll start with a 10x squared plus a 37x and minus a 12. It's just far easier, in my opinion, to factor with a positive leading coefficient than a negative. So that's the reason I do that. Checking this sign at the end is a negative, so my parentheses will be plus minus or minus plus. They're going to be different signs. My first times first is 10x squared, so that might be x times 10x or 2x times 5x. The last times last is 12, so 1 times 12 or 2 times 6 or 3 times 4. And then of course we can reverse those as well. So there's some extra possibilities over there. Remember to bring that negative 1 in front, and we'll put our parentheses. The O and the I terms this time need to have a difference. Since the signs are different, they'll need a difference of 37x. So let's start out trying x and 10x. Now if you think about this for a minute, looking at your combinations, 1 and 12, in order to have a difference of 37x, one of those numbers has to be pretty big. 1 and 12 is not going to do it. 2 and 6 would be 20 and 6. That's not going to do it. What about 6 and 2 would be 60x and 2x, which is too big of a difference. So let's check 3 and 4. 3 and 4 would be 30x and 4x, which is a difference of 26x. What about 4 and 3? 4 and 3 would be 40x on the inside and 3x on the outside. And the difference here is 37x. So that's the combination that's going to work. And in order to make a positive 37x, I'm going to need my 40x to be the positive number and the 3x to be the negative number. So I'm going to, in order to make this a positive 40x, I put a plus on the plain number here, plus 4. In order to make this a negative 3x, I put the minus with the plain number there. So that's going to factor into negative 1 times x plus 4 times 10x minus 3.